we've got one of our customers, Ian, has sent in, he's a licensed amateur, and he sent in a York 863, which is in lovely condition, but he says is as deaf as a post. It's a radio that's previously been converted to 10 meters FM, and he's converted it back, thank goodness. So it should work nicely, but it doesn't, and so we just need to look into what's happened. Although I don't see hundreds of these, I probably see more than he does, and therefore that's one screw on the floor, and therefore I should be able to spot something which may well have been changed. Perhaps somebody's put a crystal filter in it, which it shouldn't have, and have done it wrongly, and then we can change that back to a ceramic filter. It could be something as simple as that. If somebody's fitted a crystal filter and it's okay and it works, then we'll leave it. But if it's been done wrongly, then out it comes. So quick visual inspection, it looks just as lovely inside. And it's a ceramic filter which is there, so that should be fine. We'll take the bottom off as well. We're bound to have to go underneath. It's amazing when a radio is 39 years old and it's still in this condition. Now we've got capacitor under there, which I don't think should be there. Let's look at a scrap chassis of a York 861. So we have a capacitor there. We shouldn't have a capacitor there. That could be the snag. They may have altered it to try and bring up the receive. You know, I think, but that's actually in the transmit line. Oh well. That's the end of that idea. I've not got a power lead, so we'll put our crocodile clips onto it. Switch on. It's on channel 20. So we want that in high, we want that in normal, we want that off, we want that in normal, CB and 0, RF gain to full, mic gain to full. We'll plug in the test instruments. Right, well it isn't deaf. The manual says, you know, I'll dig the manual out and show you. It certainly says better than 0.5, and it is better than 0.5 microvolts. So I don't know whether the chap's got issues with his signal generated attenuator. But just trying to find the manual. We'll use the tatty one. So this is for the Rotel 240. So they say the receive is supposed to be better than 1 microvolt at 20 decibels noise quietening, which is exactly what we're doing with Synad. So if we put that up on our other camera and put picture in picture on, which has actually appeared. Oh, so I'm showing that at 12 at the moment. So there's the 12 which we're hovering around. So we put this to 20. So I'll increase the signal till we get to 20. Yeah, it only just does. Can only just do 20. So it is slightly out of spec. It's 1.3 microvolts for 20 dB, but on the 12 it's quite good. So it's not insensitive. I just wonder if the detector's set up wrongly. So we'll go through various things to get to that, and we'll start with the transmit. So I'll tell you what we'll do. We'd better just write out what it's actually doing as I have received the set. So RX, it's doing 1.32 microvolts for 20 dB Synad, and the phone's ringing. Well, that was my retired friend Bob. Used to be in the RAF, not flying, by the way, just other duties. And I sometimes think that, I mean, he's in his 70s, and I don't think he realises I'm actually at work. So, where have we got? So it's doing 1.32 for 20 decibels. So let's look at it for 12. So it's doing 0.392 for 12 dB. And let's look at 10 as well. That's how cheaper sets are sold. 0.32. So that's covered that. So let's look at it on transmit. So I'll switch over to this meter. So I'm going to start off on the 3-watt scale. So we should have full scale deflection. We have. On the 30-watt scale, we should be. That's 5 watts. So that's 4. I'll just do that test again. I was in the wrong mode. Are we on low power? Yeah, high and low power, the wrong way around. Yeah, so the switch has got rewired, hasn't it? Wrongly. So it's doing 350 milliwatts on. Oh, I've got myself confused now. It's doing 300 milliwatts. I'll try and bring that up to 400 milliwatts. And then on the 4-watt scale, it's doing 3.4 watts. So, as you can see, we've got more than 3 watts if we've got it on the 3-watt scale, and when we come down to it, there's 5, and so we've got 3.4. I expect it's on frequency, but I'll just check. You know what? It's miles out. It's miles out. Switch that over to there. In fact, it's so far out, I think it's out of tolerance if I looked it up. Right, so we'll do that. And we'll just check the VCO. I need to put it onto the... I'm going to have to hold that on because we've pinched the clip, haven't we? Resistor 4, far side. So I'll always have to recap this procedure. So it's channel 40. And what should we have? 4 volts. So that's as near as, damn it, 4 volts. And then on transmit, so I'll key it up and then I've run out of fingers otherwise. 4.01. So we'll go to channel 1. So on receive on channel 1, they want it to be between 1.8 and 2.5. It's 2.5 to me, that's fair enough. 2.61. It's in lock. I'm gonna let that go because it's you know, it's courses for courses, different meters, all that kind of stuff. That's all right. It's solidly in lock. So we'll run through the transmitter. And if I can't get it to come up to 4 watts, we'll deal with it with that, we'll take that capacitor out. So I'm now looking for the green plastic trim tool that has a mind of its own. Okay, so we want that for maximum. That for maximum. That for maximum. So that's actually just a whisker from 5 watts. Now what we need to do is to adjust L4 clockwise for 4.4 watts. So clockwise. So we're now detuning it downwards. That's 4.4. And then L9 counterclockwise for 3.8 watts. Well, we're not doing it for 3.8, we're doing it for 4. So now we need to check that we've got somewhere near on channel 1 and 40. So on channel 40, it's 4.1 watts. On channel 1, it's 4 watts. On channel 20, where we set it, it's 4.02 or something like that. So that's absolutely great. So we've brought that up nicely. So the sequence there wasn't quite right in how he'd got it. what did we say? It was 3.4 watts. Now 4 watts, we've done that. I think what we ought to do is look into rewiring his high-low power switch. Turn the power off. So the wiring here is going to be back to front. So we've got the orange wire, the grey wire, the blue wire. I'm sure if we look at my York 861 here, hopefully it's the same. So it's the it's the stripy wire, the grey wire, the orange wire. Yeah, so the grey wire goes to centre on both sets. The orange wire goes to the top on this York, which is wrong. It goes to the bottom on the 861, which is correct. And the white wire with the blue tracer becomes a blue wire on this set. So yeah, they just want turning round. So I'll just do that off camera. Right, we've got that the right way round now, so now we'll adjust the preset. Usually they could do with cleaning, so we may as well before we even start. So we want 400 milliwatts, and that's bob on 400 milliwatts, as they say. And then on the high power, oops, wrong switch. On high power, we should have, yep, full scale deflection and doing 4 watts, which it is. Good. Right, may as well set the deviation. So let's see where that is. Wallow, 1 2 1 2 1 2 wallow. That's spot on. But it's not set right, so I'll redo it because that needs to be in the centre. We'll have the wrong mic gain how it was set. Wallow, that's now spot on my way. So that wasn't difficult. Like this one in the centre position, to be honest, it's kind of linked with mic gain and that. Anyway, now got that reset, and now we want the meter on the front to read 4 watts. Now it is 4 watts. Boing, it goes right across because it says it's 5 when it isn't. So RV4, just pop that in for 4 watts. So that's transmit done. Receive. So make sure I haven't adjusted anything inadvertently. So with the cyanide meter, set that round about 4 decibels. So I've got the attenuator now at, well, about 0.3 of a microvolt. And we'll see whether we can tune it. So some of his deafness would be the radio was a bit off frequency. Oh no, that was way out, way out. That's gained a pile more. Spot on. Slightly damaged core on this one, but it's fine. Let's check that attenuator. What am I talking about? Let's check the detector with the oscilloscope. So we're looking for maximum output. This is just looking at audio. It's nothing clever. So we want an S9 equivalent signal, and all we're doing is making sure we've got the maximum recovered audio. That was already spot on. So we'll stay with, I'll take the oscilloscope off, save electricity, and we'll go back to the synad meter. We'll carry on with the IF ones. I want less signal for these particular ones. We'll put it to about 12. Now I've got an increase there. We've got an increase there. We'll recheck this one. There. Right, that's where we are. Shall we just check that very first one once again? Some of this is interactive. No, all spot on. So that was quite a bit out. Some of these IF ones were a bit out. That should give us a different result. So we'll keep our eye on the synad meter. 20 dB. Is there. Let's see what that reads. So at 20 dB, we've now got 0.72 microvolts. For 12 dB, we have got 0.23 microvolts. I'm going to have to change scales for the next one. In fact, we'll do that one again on the other scale. 12 dB on the other scale. Yeah, it's 0.25 on the other scale. So we'll give it the worse figure. Or the inferior figure, should I say, with better English. Can't quite do it on that, on there. So on the next one, it's 10 dB. I would like to say is there. 0.22 microvolts. So that well exceeds the manufacturer's specification, and that's a good radio, because this one can be as poor as 0.7. It's often 0.5. Some better examples, 0.3. 0.25 is exceptionally good. So that'll make a huge difference to him. Now we need to set this for S9. So at the moment it's banging across. Now, oops, S9 shorts out the power lead as usual. And now we need to check the squelch. So turn the radio to full squelch. Let's put the camera on the attenuator. You can see it for all the wires dangling. So at the moment we're at 1 microvolt. So the big hand's at 1, the small hand's also at 1, so it's 0. So if we turn the squelch down, you'll hear that well. Let's turn the squelch to full. What should happen is at 100 microvolts, the squelch should open. That's a squelch at full. So we don't want it so that the squelch never opens. And a lot of radios where it's got adjustable internally adjustable squelch, you can do that, which is rather daft. 3, 10. No, he's too weak. Weak as dishwater. Let's try it there. Still too weak. That's spot on. 100 microvolts. So now at the sensitive end, we'll park it at 0.3 of a microvolt. We'll turn the signal generator to standby. So the red light there tells me the signal generator is on standby. Turn the squelch down. Set threshold on the radio. Switch the signal generator back on. Now, the radio will probably pop on for 1 second whilst the signal generator sets its level. There we go. It's set its level. So we now need to find what that level is. So it's obviously beyond the squelch at 0.3 of a microvolts. Turn it to 1, and now just the fine tune one. So we've got the squelch going off at 0.45 microvolts, coming in at 0.53 microvolts. So there's nothing wrong with that. They're not the best squelch in the world on these, but it's competent squelch, and this radio works fine. There's no distress capacitors in this set. So we've brought it on frequency. We've sorted out the reason that it wasn't doing 4 watts, balanced up that, got a lot more out of the receive. His detector was correct. His deviation was correct, but we've reset the way that is. His squelch was way out, and his meter was way out. So there we are. I may as well turn my soldering iron off, and all we need to do is to put that radio together, and we'll just flick round the channels and find nobody's on. Right, we're now on the roof aerial. Because we're not using a proper power lead, I'll have to hold it up from the bench, otherwise it's going to drop off. So it's now 10 past 12, noon. One down to Roger. So notice how it smoothly changes from one channel to another channel. There's no muting whilst it decides what channel it's on, like with modern sets. When I press transmit, it's straight into transmit. 19 Roger. You know, this is the thing, isn't it, between the new ones and the old ones. I do prefer the Rotel 230 or the Harvard 420M with the less knobs and the same chassis. If you go down to the 220, the Rotel 220, the York 861, you get a receive stage less, so they're not quite as good. But certainly with this chassis, you get on the 230 with less knobs, and that suits me better. Well, it's a splendid set. It's in beautiful condition. It's a credit to the owner, and we'll do an on-the-air test with Mr. Chippy later on today. So thank you for watching the York 863 service.